Hello, everyone. Welcome to implementing scalable storage for Kubernetes on GCP. Container mobility requires data mobility. I'm Jerome McFarland, VP of Marketing at Elastifile, and I'm going to be joined today by my co-presenter, Katrina Mulliken, Technology Director and Cloud Whisperer at the HudsonAlpha Institute for Biotechnology. Now, in today's session, we're going to be talking about the critical relationship between container orchestration, as facilitated by Kubernetes, and the underlying data that many containerized workflows need to persist and manage. Now, as a framework for this conversation, I'm going to take you through a simple use case example involving web services implemented across a hybrid cloud. And this example is going to let us discuss and illustrate some of the key considerations around data management and data mobility for these types of containerized workflows. Then Katrina is going to join us, and she's going to take you through a different use case and a demo, illustrating how HudsonAlpha is leveraging Kubernetes to manage data-centric workflows across hybrid clouds in the scientific computing domain. So by the end of the session, you'll have gotten a flavor for a fairly broad set of different use cases in this area. So let's get to it. So as a framework for the web services use case example, I want you to think about a multi-platform advertising campaign. So in this advertising campaign, we're promoting a product called Elastifile. It's this naturally essenced, gluten-free, zero-calorie beverage that Elastifile has decided to put out. Now, in an effort to promote Elastifile and drive traffic to our Elastifile website, where we take orders by the caseload, we've decided to splurge a bit and purchase some commercial time during the recent World Cup final. Now, having high confidence in our marketing team and the effectiveness of the commercials that they're going to design, we expect a massive influx of traffic to our website as a result of our new commercial. So of course, we want to maximize our ROI, we want to get the best bang for our buck, so we need to make sure that our web infrastructure supporting our website can scale effectively to support this increase in load, this increase in demand. So that's the challenge before us. Now, this type of a challenge, it's a fairly common one to many organizations who are looking towards the cloud as a way to extend their IT. They may have some sort of bursty workload or some increase in demand that they're expecting, and they want to leverage elastic infrastructure to be able to scale to support that demand. Of course, the cloud has near infinite elastic resources, so it seems like a perfect fit, so we should just tie everything together and make it all work, right? Should be simple. Well, unfortunately, as many of you may have experienced, if you've tried to implement these kinds of workflows in the past, the making it work part hasn't necessarily always been so easy. Right? In many cases, especially when you're dealing with data and the considerations around data, you may have found yourself implementing isolated storage islands in the cloud. You may have found yourself pushing data into the cloud with manual type of forklift migrations to manage the data in the cloud. You may have implemented complex schemes to copy data between storage islands in an effort to create some semblance of synchronization or data sharing. Right? Now, of course, these types of manual methods, they definitely can work, but they can be extremely painful. Fortunately, with what Kubernetes has brought to the table, and with the data management technologies and techniques that I'm going to be describing and that we'll be demoing today, implementing these sorts of workflows is easier than ever before. Now, before we get into the implementation and some of the specifics around that, I want to take a quick step back and see kind of how we got here. So as you all know, right, no surprise, containers are everywhere. At this conference, at almost any conference in this space, Kubernetes, Docker, containers are on everyone's lips, right? And that's been the case, honestly, for the past several years. But the thing that's changed more recently is many workflows, and core use cases are now being targeted for containerization that previously may not have been considered to be a containerizable, if I can make up that word, a type of a workflow, right? Containers and Kubernetes are no longer the exclusive domain of stateless applications and freshly written microservices. People want to use them for much, much more. And Kubernetes orchestration isn't just making these expanded use cases possible, it's really making them easy. And when you think about these expanded use cases, data is a big part of them, right? We all know that Kubernetes and containerization offers massive benefits for packaging and mobilizing applications. And to extend those benefits to core workflows that involve data, you need a persistent data management layer, right? You need something to be able to store and manage data beyond the lifecycle of a given container or a given pod. So these types of solutions become necessary as you extend the scope of workflows and use cases that you're leveraging with containers. lots of different applications have these requirements, right? From examples that involve web services, like we'll discuss today, to any kind of example that persists or manages user data, to a broad range of industry-specific applications and domains like scientific computing for life sciences, or financial services, or media entertainment. And there's many, many more examples. Now, fortunately, Kubernetes, in anticipation of these requirements, has evolved to supply services that help you address these data-centric requirements and data-centric needs, right? With Kubernetes persistent volumes, you can seamlessly integrate data storage, persistent storage layer into your Kubernetes deployments. With Kubernetes storage classes, you can control and manage the dynamic provisioning of storage by leveraging Kubernetes volume provisioners. And with stateful sets, you can manage the ordering and management of certain sets of pods or containers within Kubernetes. So with all of these flexible capabilities and integration options that Kubernetes has given you, you have a lot of choices and options for what to do on the data side. So what should I deploy as a data management layer? What should it look like? Should I be deploying file storage? Should I be targeting block storage? Should I be looking at open source solutions? Should I be looking at vended solutions? So next I'm going to go through some of the key considerations, at least in our view, that we think you should be taking into account as you think about what types of stateful services and what kind of data management layers and data management platforms you should be deploying. And then I'll introduce you to a qualifying solution from Elastifile and take you through the demo flow of our web services example. So first key consideration, and there's going to be four. The first one that I want to talk about is usability. And when we think about usability, we're really talking about ease of integration, ease of adoption, ease of use. And from the data management and the storage perspective, you're really talking about how you interface with the data. And so really what kind of storage you're using. Are you using file storage, using object storage, using block storage? And in our view, file storage makes a lot of sense as the default storage platform and storage interface for stateful containers or for persistent storage implemented with Kubernetes because of the broad range of applications and workflows today that rely on a file system and expect a file system, right? At last year's Next, in one of the presentations, Descartes Labs noted that 90% of the calls in the open source GitHub repository were the storage interface calls were calling fopen, right? So they're expecting a POSIX compliant file system underneath. And those was by far the most prevalent type of storage that was being called, more than an order of magnitude over any other type of storage, including object. So really think file is the way to go. In addition, of course, to being application usable and application accessible, file systems are also human usable and human accessible. You know, we're all very familiar with file and directory hierarchies, what those mean, how to traverse them. So leveraging a file system provides a high level of usability in conjunction with your containerized workflows. Another key criteria to consider is scalability, right? As we all know, Kubernetes offers amazing capabilities for scaling application deployments and scaling your ability to handle workloads. So when you're implementing a persistent storage layer, you want to complement that. You want to have something that can scale to support the capacity and performance requirements at the storage level to meet your needs of today for your workflows as well as your evolving needs as your workflows may scale. Third key criteria is shareability, right? You want to get away from dealing with storage islands, right? It's a problem. It can create a lot of complexity in data management. So if you have a solution that can allow you to share data across your infrastructure, so across your nodes, across your storage devices, and present single namespaces that can scale out, that provides huge benefits to enable seamless collaboration across applications, across users, and across workflows. And the final key criteria that I want to discuss is around data mobility, right? So as we all know, Kubernetes provides extreme power for application mobility, the ability to package and mobilize applications. So having complementary capability to package and mobilize your data, it can be hugely beneficial, especially when we're talking about hybrid workflows and the needs that arise to take data from on-premises and be able to leverage and access that data in the cloud. So here are 4 key criteria, and now I'm going to talk a little bit about the Elastifile solution, and of course, you know, we feel that we meet these criteria fairly well, and give you a sense for how you can leverage us as we go through the demo flow. So in a nutshell, the way to think about Elastifile is enterprise-grade, scalable, POSIX-compliant file storage for the cloud, right? You can deploy us in GCP Marketplace, and essentially we consist of 2 key components. One is the core file system itself, the Elastifile Cloud File System, or ECFS is what we call it for short. It's a software-defined, scale-out, distributed file system. The other key component of the Elastifile solution is what we call Elastifile Cloud Connect. And what Cloud Connect does is it delivers data mobility between file systems and object storage. and really allows you to combine those two storage paradigms to get the best of both worlds. And I'll go into a little bit more detail about how Cloud Connect comes into play in these sorts of containerized workflows and across hybrid clouds in just a moment. But first, a bit about the file system. So ECFS, it's a software-only, environment-agnostic file system, right? So you can run it in any cloud, you can run it on-premises as well. And essentially what it's doing behind the scenes, it's aggregating the storage resources of your cloud VMs and presenting them to your applications in a single shared namespace, right? And what it delivers to those applications is POSIX-compliant primary storage. And when I say primary storage, I mean this storage is meant for applications and workflows and users to interface with directly, right? It can support transactional workloads. And it's really built for the cloud. All of the services that underlie the Elastifile solution are distributed, including the metadata management. As many of you who deal with storage may know, metadata management can often become a bottleneck to performance as storage systems scale. So our solution was designed for the cloud, and so the metadata management model was implemented in a fully distributed fashion to ensure that you can scale effectively with performance scaling linearly as you scale out. Now, to the user, what Elastifile provides is scalable capacity and performance, right? You have the ability to add capacity to your cluster in a hot fashion, a dynamic fashion, without bringing the cluster down. You can remove it if necessary. And as I mentioned before, performance is going to scale out linearly as you add capacity as well. Full enterprise feature set, including snapshots, data reduction through compression, deduplication, high availability, asynchronous replication, etc. Everything that you can do with Elastifile through our GUI and through our CLI is also fully REST API controllable. So you can implement seamless workflows leveraging infrastructure as code like Terraform or Ansible as well with Elastifile. And as I mentioned, it's easily deployable at the push of a button through the GCP marketplace. So I'll just quickly show you a quick deployment. We're going to spin up an Elastifile cluster here. So we're going to call this one Google Next Demo. So you can do this through Marketplace today. You're going to select your zone, some basic networking information, and you're going to hit deploy. Now, what's actually going to deploy here is the Elastifile management VM. That management VM is going to give you access to our UI, and from within our UI, you're going to be able to specify the characteristics of the cluster, the storage cluster that you want to create. The most important one, of course, being the capacity that you want to create. So here we're logging into the Elastifile UI. So when that's done, you can see our management VM is up and running from our management console there. We're going to select the type of storage that we want, and we're going to add 9 terabytes of capacity for this particular cluster. In this case, that's going to correspond to spinning up 3 instances in GCP. And if we go to the compute engine, we'll be able to see, you can see the management VM as well as those 3 storage nodes that are going to be part of our cluster. They've all been started. And so if we go back to the Elastifile UI, you'll be able to see the deployment finishes, and now you have a cluster available with the capacity that you specified. So that's how easy it is, right? You can just spin it up, the click of a button, GCP, put the capacity you want, and we're up and running. Now, through that UI that you just saw a preview of there, you can do lots of other things. You can manage capacity and monitor capacity. You can also manage and monitor performance. You can also look at the status of your environment, like the number of nodes in your cluster, the number of physical devices, the number of connections, etc. You can also scale the cluster through that same UI, right? You saw us deploy it and specify a certain capacity. You can also scale it. And we're continually offering more and more options for the types of storage and the granularity of storage that you can deploy in a cluster to give you more options to create the types of cost and performance trade-offs that you want in your environments, right? Even since the time when we recorded that previous demo clip, we've added additional options for adding capacity and deployment capacity. You can see here we're showing SSD persistent disks and standard persistent disks. You can also drill down into performance. You can look at it at the high level. You can also drill down into certain timescales. You can also look at performance for certain call them collections of data that we call Elastifile data containers that are segments of data within your file system that you can choose at your will as desired. And a data container is something that you can basically configure with certain policies. So you can say for this data container, this collection of files and directories, I want compression to be on, or I want deduplication to be on, or I want both of them to be on. And you can also set quotas. So it's a way of managing collections of data inside of your contiguous file system. And finally, you also have the system view that enables you to see the health of your environment on a continuous basis. Now, once you've got an Elastifile file system spun up in the cloud, you want to leverage it with Kubernetes, right? So to connect it into Kubernetes, we've also just released, just last week, the Elastifile Storage Provisioner, also available through GCP Marketplace. And what the Storage Provisioner does, kind of calling back to those Kubernetes functions that I mentioned before, it creates a storage class for Elastifile storage within GCP. And through that storage class, which you can see here, you can connect a cluster, and you can now specify persistent volume claims and persistent volumes that leverage and deploy Elastifile storage on a dynamic basis. So now you have the ability to connect in Elastifile simply into any Kubernetes deployment by leveraging this provisioner. So if we go back to our checklist really quick and see how we're doing, usability, file interface, right? We provide NFS file storage, so we're very user and application compatible. It's POSIX compliant, and the key thing around POSIX is the strict consistency. So if an application writes data to our shared namespace and another application tries to read data, the application that's reading is going to get the latest data that was written, right? It's strictly consistent. Fully REST API controller that I mentioned before, and we have a Kubernetes volume provisioner available in the marketplace. So I think we're doing okay on usability. Scalability, as I mentioned, fully distributed metadata model, so allows you to scale out with linear performance scaling. You can add capacity, remove capacity as necessary, so highly elastic. Shareability, again, it's a shared file system, so you're unifying all these resources within a single namespace. So all VMs, all pods, all users can access the same data regardless of where they're connecting in from the file space. So the one piece that we haven't talked about yet is the data mobility piece, and that's where Cloud Connect comes into play. So as I mentioned, Cloud Connect manages the transfer between file and object, right? And it's a bi-directional transfer that it can manage, and it really blends the best of both worlds in use cases that involve both hybrid data management, so from on-prem to cloud, and also in-cloud data management between object and file. So the thing to understand about Cloud Connect is really what it's doing is it's helping you to encode the data of any given file system into object storage so that it can be stored there in an inactive state until you're ready to use it. And then when you're ready to use it, you can pull the data out, again, using Cloud Connect into another file system. So in a hybrid mode, like what I'm highlighting here, what we would do is you can start with data on-prem from any on-premises file system. It doesn't have to be Elastifile, but it could be. What Cloud Connect will do is it will compress the data, it will dedupe the data, it will encode the data into object storage format, so in this case into a GCS bucket, and we're going to retain all the file and directory hierarchy information, all the attributes, all the links, everything about the file system, but encode it into object format. Then when you're ready to use that data in the cloud and process it natively in your file system, in your primary storage, Cloud Connect can also allow you to then check out the data. So putting it from file to object is the check-in. You can also check out the data from object to file and put it into an Elastifile file system that you're running in the cloud. You don't have to pull out the whole namespace. You can pull out certain files, directories, up to you what you want to pull out. So again, we try to be very efficient about how we transfer the data because that can be a painful component for many organizations. So we compress the data, we dedupe the data, and after an initial synchronization, let's say from file to object in the cloud, any additional transfers will only ship across the diffs. So we try to be very efficient there. And Cloud Connect is also fully REST API controllable. So anything you can do through our UIs, you can do it, you're using REST as well. And the key thing to think about with Cloud Connect is this concept of a connection. And this connection, the connection has a source and a target. And in the case of going from on-prem to the cloud, your on-prem location is going to be your source, and your cloud bucket is going to be your target. So now let's go back to our use case example, right? So our Elastifizz. We got this amazing product, we got this commercial, we're ready to scale our infrastructure. So as a starting point, we've got some new data for our Elastifizz campaign that we got on premises, and we want to get it into the cloud, right? To start off, we have a little bit of data in the cloud, as you can see here. We got a couple simple Elastifile logos and stuff, but we want to bring over some of these new characters and some additional logos to get ready for this commercial and the influx of visitors that we're expecting to our website. So we want to stage this data and get it into the cloud. So we're going to use Cloud Connect to bring the data over from our on-premises location into GCP and into GCS. And that's what we're going to show here. And it's a pretty simple process. And the first thing is, let's just look at the state of our environment. So we go to our WordPress backend in our media library, and you can see, as I mentioned, we've got one logo, so it's pretty lonely there. It's kind of poor. So let's go into Cloud Connect. So we go to the Elastifile UI. We're going to select Google, of course, and we're going to call this an upload connection because we're taking data from on-prem to the cloud. Our bucket name is going to be GCP Demo 1. And in this case, if we go to the Google Cloud backend, just to show you, GCP Demo 1 doesn't currently exist. Right? That bucket has not yet been created. We're going to create it as part of this process automatically. So we're going to select a check-in connection, and we're going to go ahead and perform the check-in connection creation operation here. Now, what we're doing now is we're going here and we're going to grab the source directory from our on-premises environment that has the data that we want to bring over. So these are our additional logos and files, etc. So now we've created the connection, and we're going to move forward, and we're going to actually perform the check-in. And we'll give it a description of version 1. So when you go back to the Google Cloud UI, after the check-in has been created and performed, we're going to refresh, and you'll be able to see GCP Demo 1 has now been created, right? This bucket that didn't exist is now available. If we click into the bucket, you can see it's full of objects. These objects represent the file system data that was encoded leveraging Cloud Connect. Again, retaining all the file and directory hierarchy, all the links, all the attributes of that file system, but stored in cheap and deep object format, ready for you to use. So now we've got our additional data for our campaign staged in GCS in the cloud. So let's load it into the Elastifile file system, because we're going to run our web services infrastructure on top of Elastifile, right? Just like we were running it on-prem, we're going to run it using Kubernetes in the cloud on top of Elastifile to extend our infrastructure. So let's do that. So you can see now we're going to create a download connection to check the data out. Again, we're going to specify that same bucket because we're pulling the data from GCP Demo 1. And now our target is going to actually be a file system that corresponds to a persistent volume claim that was created using Elastifile's storage provisioner, right? So we connected into Kubernetes with that storage provisioner in our storage class. So we're going to specify that is going to be our target. So we put that data in there, and we're going to create our checkout connection. So with that connection created, we're going to actually perform the checkout. And here you can see some options for how you handle files on a checkout if they were already existing, etc. So we'll pull the checkout. That happens. If we look in our in-cloud file system, you can see an image upload directory has been created that wasn't there before. And if you look, there's several files in that directory. So just to close the story, we'll go back to our media library. We'll look, okay, image upload directory, that's the one that we just created with our checkout. We're going to select a few files, pull them into our media content library. We'll take a look and see what they are. And there you can see, we got some additional logos, we got our cool little characters, so now we're ready, right? Our website is now primed with the additional content that we want to leverage in our scale-out infrastructure to support the influx of visitors from our commercial. So that's great. So we got the data in the file system. Yeah, question? So you can use rsync to bring data across, but with Cloud Connect, you get a lot of granular capabilities to manage the lifecycle of the data, in that you can have data stored in object until you're ready to use it, let's say. You can pull it out into the file system. When you're done with the data and processing with the file system, you can push it back into object and spin down the file system. So Cloud Connect gives you a little bit more granularity on how you manage the lifecycle of data, whether it's stored in object or in file, right? So again, we're trying to blend the best of both worlds there. Rsync might be characterized as one of those kind of manual methods to bring the data over that I mentioned before. All right, so now we've got the data in our file system, so we're ready to go. So let's just do a little bit of work. Before we do the work, actually, let me come back to the data mobility piece and just make sure we close that. So we've shown hybrid cloud connectivity, we brought data from on-prem into the cloud, and we've shown the connectivity between file and object. And one thing I didn't mention is that Cloud Connect is bidirectional. Of course, I showed a flow bringing data from on-prem into object, and then from object into the file system in the cloud. You can also bring data back, right? You can bring it back into object from the file system. You can take it from object back into your on-premises environment if so desired. So I think we've covered the data mobility. So let's just do a little bit of work. Let's make sure that everything kind of fits together and actually works properly. So here we've already got a WordPress deployment spun up. You can see one WordPress pod. I also want to highlight that we've got this DB loader pod here. And what that's doing is actually generating synthetic I/O reads and writes on the back end of our storage infrastructure and just hitting the Elastifile cluster with some reads and writes. So we want to make the cluster work in addition to the read commands that are going to be coming in through JMeter, which is what we're spinning up here, generating some workload through our web infrastructure. So we've got the web workload, and we've also got some back-end I/O, and that'll come into play later. So you can see everything seems to be working. We're handling about 44,000 read requests per minute, so we're able to handle some traffic to our website. So that's interesting, but really with Kubernetes, what you want to be able to do is leverage the scalability, right? So let's scale the front end, right? Let's get some additional WordPress front end pods going here in our GKE deployment. So that's what we're going to do next. So here you can see, got the initial WordPress pod that's there. So we're going to scale to 4 replicas using kubectl. We'll do that. You'll be able to see there's now 4 WordPress replicas up and running. So we've scaled our front end, and you're going to see the performance is going to scale up of our cluster as well. So we went from around 45, and we're going to scale up to about 70,000 requests handled per minute. Now, of course, scaling the front end is only one piece of the story, right? And Kubernetes provides seamless capability to do that, as we just discussed. Scaling the backend and scaling the storage can also be an important part of the story, right? What if you need additional capacity? What if storage has become the bottleneck to the performance for your given applications? So you need more scale out performance. So of course, with Elastifile, as I mentioned previously, you can scale the file system as well. So we're going to show you quickly how to do that as well to control all parts of your infrastructure. So as I mentioned before, we had that one DB loader that was running and generating some synthetic I/O on the back end. So before we scale our cluster, we're going to scale that DB loader. So you can see we've now created 4 replicas for that DB loader. So we're increasing the amount of I/O that's hitting our file system. And the reason that we do that is because we wanted to be able to show in the performance UI for Elastifile, you can see the performance of the cluster scaling up, right? In conjunction with that additional I/O that's being hit, we can see the additional performance growth there in the UI, all while actually maintaining a fairly low latency at under 2 milliseconds. So you're able to see the ability to monitor the performance as your environment workload changes. So now let's actually add some capacity. So here we're going back to that same UI. I'm going to add 3 terabytes of the type of storage I've selected. So in this case, that's going to correspond to spinning up 1 additional node. Right? So as we saw before, that's happening in the back end on GCP. We're spinning up that additional infrastructure to supply that additional storage. So you'll be able to see now that node is now active and available in our cluster, or what's ready to deploy in our cluster. And we're going to deploy it, and that's going to make it active. So once we hit deploy, now seamlessly in the background, that additional capacity is being added into our cluster. You don't need to take any additional actions. Your cluster performance and capacity are going to extend with those additional resources seamlessly simply by deploying it and adding it. And as you saw there, it's now active, and now we have 4 storage nodes in our cluster giving us additional capacity and additional performance. So we've actually done quite a few things here, right? We started with some data on premises that we wanted to get into the cloud. We spun up the Elastifile file system seamlessly, so we had that storage capacity available there. We pushed the data over into object storage. We decided, okay, we're ready to load the file system, so we pulled the data out of object into the file system. We scaled our WordPress infrastructure, and then we scaled our storage infrastructure. So we've done quite a few things in this kind of simple use case example, but really, storage and data management for Kubernetes are not topics that only relate to web services. They relate to a much broader range of applications and use cases. And with that in mind, I'll now hand over to Katrina from HudsonAlpha, who's going to take you through a different use case in the scientific computing domain. Not in this example, no, but you can use stateful sets in conjunction with us.
All right, thank you, Jerome. It's great to be here. Hi, everyone. I am Katrina Mulliken, Technology Director and Cloud Whisperer at HudsonAlpha. HudsonAlpha Institute for Biotechnology is a nonprofit genomic and genetic research institute located in Huntsville, Alabama. We leverage the power of the human genome sequence to better understand causes and early indicators for complex diseases such as cancer and Alzheimer's, and the genetic causes of rare and undiagnosed diseases as well. We are a genomic sequencing leading facility in the world for human health as well as agri-science endeavors. Researchers, entrepreneurs, and educators collaborate with each other and over 40 associate companies located on our 160-acre campus in Huntsville. Our education program provides on-prem and virtual curriculum for adults and students, their teachers, and lifelong learners around the world. And HudsonAlpha is also home to the first standalone genomic medicine clinic, which uses genome sequencing data to provide patient diagnoses. So that's a little bit about HudsonAlpha. One of the great things about HudsonAlpha is our ability to rapidly adopt emerging technologies. And to do this, we, in IT, have a DevOps mentality and treat infrastructure as code. So our on-prem composable infrastructure provides the backbone for a variety of use cases, including the one shown here, which is an on-prem Kubernetes cluster built on bare metal. The Kubernetes master and several worker nodes are provisioned using open source tools such as CentOS and Python and HashiCorp Console. Console provides service discovery, and Datadog, which is a cloud-hosted monitoring service, provides information about our uptime and monitoring application and infrastructure performance. So what we're going to do today is talk about the power of provisioning this on-prem Kubernetes cluster as code, and then show why and how it can become a hybrid cloud Kubernetes cluster by extending onto GCP. So first, let's take a look at the process of provisioning this on-prem cluster. It's really tall. Okay, so here you'll see some Python. So this is just a way to provide configuration for the master and worker nodes here. You can see things like enclosure numbers, bay numbers, template names. These are all custom attributes that are read by scripts that work as the nodes come up for the first time and provide a personalization experience. So the nodes know their role, what they're supposed to do. Console plays in here also. The roles can read key value pairs and write key value pairs. So awareness of other nodes happens through this process. There's a simple common provisioning script that is used for all of our use cases. You'll see it makes a connection to one view in this case for our composable infrastructure. It parses the configuration from the master and the worker files, creates server profiles, sets custom attributes that will be read by those startup scripts. And so the whole point here is one line of code and the environment's provisioned. You write this script one time, you check it in to version control, and this speaks highly to accuracy and speed of delivering the resources. So with this one line right here, I'm going to go ahead and provision a Kubernetes master node. All right, it's already starting to come up. So let's take a look at console. Console runs as a Docker container. See right here. So in addition to key value pairs, it also provides service discovery and IP address, host name, and status of every member that talks to this console server. So right now I just have myself, but as things are provisioned, this is a one-stop shop for me to come type this command, see what's in my environment, and be able to connect to it. All right, looks like this one just powered on. That's the master. So we're going to rerun this same script, but this time create a worker. And I can repeat this for as many resources as I have. I can keep coming up with workers, and we do, of course, have multiple workers in our cluster. So we're waiting for that to come up. I'm going to go back to console and actually check on things here, see if the master is showing up. Looks like the worker just came on. There's our master. And we'll see the worker in a moment. So one of the things that the automation does is it embeds SSH keys, which allows me to do a passwordless connection as soon as the node's up. As soon as I verify it's up with console, I can do a passwordless connection into the Kubernetes master. So remember, the only thing I've typed is a Python script with an argument. I mean, I have not done any Kubernetes setup at this point. This is all automagic, part of the provisioning scripts. So here we come into the Kubernetes master. I'm going to do some sanity checks to see if it knows about the nodes, and it knows about the master. It looks like the worker, it's been 20 seconds. It's not quite ready, so I'm going to give it just another couple seconds and check back. There it is. Another thing that the automatic scripts do in this case is they embed Datadog monitoring as a daemon set. So that's the next thing I'm going to check on, is to see if this happened. It'll automatically deploy a daemon set per worker node. And of course, Datadog was, like I mentioned, it's used for monitoring and of uptime and performance. So let's see, we do have a Datadog agent running on our worker. So what I'm going to do, just for the purpose of this demo, is just an Nginx deployment to show you. We're going to start with 3 replicas so I can scale it up later and see how this works in just a little bit. So starting with 3, just your typical Nginx. This is sanity checking for the environment to make sure that my cluster and the API are working. So. All right, and just as we expect, we have containers creating, and there's our pods. So far so good. So this is all on-prem, bare metal, Kubernetes provisioned as code on composable infrastructure at HudsonAlpha. And as a final check, we'll just check on Datadog while we're at it. Yes, those daemon sets are running, so I should have my master and worker, and I should be starting to gather, it just is now coming up, but starting to gather these metrics. But, so what if the on-prem environment is not enough? You know, genomics takes a tremendous amount of data. We generate about 5 petabytes of data each year. And one of the tricks with running in cloud is how do you get your data into the cloud? So as Jerome mentioned, Elastifile is helping us do that. The amount of compute can sometimes not be sufficient in your on-prem environment either. So let me just give you a genomic sequencing 101. When DNA and genomes are sequenced, that's represented as data. So you take the data from a sequenced subject, you compare it to what we call a reference genome, and the process of figuring out all of the differences between you and a reference genome is known as variant calling. It's a very compute-intensive process, requires a lot of scratch space and a lot of demand on your resources, and it's accomplished through a set of what we call pipeline, a set of tools that execute in a certain order. What happens, though, is that new versions of the pipeline become available. So we size our data center to handle the day-to-day 24/7 variant calling, right? But then when these new versions come out, researchers want to go back. In addition to the day-to-day workload, they want to go back and reanalyze everything with the new version because they might, you know, glean some new knowledge because this new version has come out. So in that case, your compute requirements are definitely stressed beyond their normal workload. The good news is that tools and pipelines are becoming containerized, and therefore a great solution, and this is what I set out to do at HudsonAlpha, was to figure out how to burst our on-prem Kubernetes solution into public cloud. And part of what makes that possible is things like a direct connect, VPN to public cloud. There are ways to connect the networks, but you also have to worry about connecting the storage. So the on-prem worker nodes access the on-prem data, the cloud worker nodes access the cloud data. So for us, that's a matter of deploying Elastifile in the cloud and Cloud Connect on-prem. I'll show a graphic in just a moment, but that was the next hurdle to overcome, is how are we going to get the appropriate data into the cloud so that these worker nodes can chew on that. The good news is console, and what I'm using for service discovery, can communicate with everybody because of that network, the private networking setup between us and the cloud. And then, of course, your workload could be manually scaled or ideally auto-scaled as soon as those resources become available. So this is how this looks. On the left is Huntsville, Alabama. Here's our on-prem compute that we just talked about with the master and workers. So I showed how easy that is to spin up. Existing NAS or Elastifile on-prem can work with the Cloud Connect node. So Cloud Connect knows about our existing data. Cloud Connect, as Jerome showed, pushes the data up to GCS, cloud storage. And then over in Google land, we can publish or push up as many Kubernetes workers as we'd like, and they all have access to that data. So the workers at the bottom here, the tool set, is very similar, except I'm going with Terraform for my provisioning in public cloud instead of Python. And we've added Elastifile, of course, to the mix. So let's take a look. This is my Terraform. So it's pretty standard stuff. Just define a Google Cloud provider. There's a few variables. Of course, at your discretion, you can choose as many variables as you'd like for the environment. This just shows some of the ones I'm using here. And one of the big differences here to accomplish the automation is that there's a scripts and a service files directory. The scripts consist of their bash scripts, but they start up all of the application that we need to and all of the automation, and then the service files are systemd files. So it really is as simple as telling Terraform that we want, in this case, I just chose a number, so we're going to say 3, purely vanilla CentOS 7. There's nothing special about that CentOS 7, and that's on purpose. I'm a big believer that you don't put the magic into the image, you put the magic into the code. So scripts and service file directories are going to be copied up, And then these commands are going to be executed automatically on each node as they boot. Some of this is to mount Elastifile in FS tab, to set up my DNS for Elastifile, and to mount that directory. So at this point, I've written the code, pushed it up to version control. I'm going to do a sanity check here with Terraform. And if everything looks good, go ahead and apply it. And we're going to watch this thing come to life in Google, and then it will automatically associate itself with my on-prem bare metal Kubernetes cluster. And this is real time here. So from the moment I type yes, I can immediately go check out GCP, do a refresh, and they're coming. Here's the 3 nodes, of course, that I asked for. Go back and shave a little bit of time off. It's been 2 minutes and 40 seconds. Everybody's up. And my favorite command, are they here? Yes. I not only have my on-prem bare metal Kubernetes cluster, I've got the 3 new worker nodes. I've got their IPs. I've got their status. So we're good to go. I can connect into one of these if I want to for sanity. I don't have to. I can say, let's connect to it once. Let's just make sure the scripts work. Let's make sure my data is there. So we're going to pick the first guy. We're going to connect to him and just do a simple DF and looking for this line. So he's mounted up, and at that point, this node can consume that directory as it needs to with the apps running on there. So we exit back. We're going to repeat the SSH to our worker node. I'm sorry, our master node. And I'm going to ask it to get the nodes. We're going to see if everybody's here. Yep. So I've got my 3 GCP workers. They're good to go. And I'm going to do a sanity check on Datadog, make sure the daemon set's functioning as it should across to the cloud. I should have one, I have 1 per GCP node over there. And then as a final demonstration, instead of auto-scaling it, I'm just going to force my Nginx deployment to go to like 30. Pick a nice number now that I've got some more compute. Yep, I've got 3 that I asked for initially. We're going to scale that up. Sorry about the typing. I guess I was a little tired. I don't know. It's kind of slow. I'm working on it. Okay. All right. Scaled it up and repeat the pause just to show. Yeah, everybody's at the party now. We've got on-prem from the bare metal. We've got the GCP nodes. And each of these can be scaled independently based on which script you're executing. If you want more on-prem, you do the Python. If you want more in the cloud, you do the Terraform. But it's all code. It works every time, and it's repeatable. At this point, you don't have to waste a lot of time with sanity checks anymore because it's going to be the same every time. So here's Datadog. They've checked in, and I'm starting to gather metrics on those already. So that's a successfully scaled Kubernetes cluster with my on-prem environment as one of the clouds, my private cloud, right? And then GCP public. So give it back to you.
Thanks, Katrina. Really cool stuff to see those types of workflows in action for real-world use cases, especially in domains like life sciences that can benefit so many of us. Just a couple of final thoughts or things that we want to leave you with here. So if you remember anything, what we'd like you to really remember is that you have the capability to leverage Kubernetes stateful services to package, scale, and mobilize a broad variety of applications and workflows, right? Again, like I mentioned before, it's no longer the sole domain of microservices and stateless applications. You can leverage Kubernetes for much, much more, including applications that need to persist and manage and mobilize data. We encourage you to evaluate your storage options very carefully, right? You have lots of options with Kubernetes, but make sure that you're really considering the key selection criteria for your workflows, right, around usability, scalability, shareability, and data mobility to make sure that you have a solution that can provide all the needs that you're going to have both today and in the future. And finally, of course, as we've been mentioning, we have a turnkey solution available from Elastifile through the GCP marketplace, both for the file system as well as the storage provisioner for the connectivity into Kubernetes. And I also want to give a special thanks to Ronan Cohen, one of my collaborators at Elastifile, who helped develop all the demos that you saw today. And finally, if you want to learn more about Elastifile, we're here in the South Hall of Moscone in booth S1503. So we've got all the experts from our teams are here. We can talk about pretty much any angle of these types of solutions that you want to go through. So we encourage you to visit us and learn more.